All right, we're continuing with polynomial functions, and we're going to take a look and see how we're going to graph these. We've got a few foundational ideas first. First is that this is some notation, really important as you move into calculus. It's a little confusing for here, but this is the notation I just want you to see. When x approaches infinity, just means that your x's are getting really large. You're moving to the right. When x approaches negative infinity, it means your x's have gotten to be down here to the left, very negative numbers. This would mean these are the y's. F of x just is fancy notation for y. So this would mean y's are getting very large. They're going up very high. And if you would have f of x equals negative y, it would mean they're getting very low. They're going down. Now, what they're doing here doesn't make a lot of sense. Let me get some clear screen here. Let's just do it right here. So there are two functions that are going to help us understand what's happening with this. One is x squared, which I hope you have the shape memorized, and the same x to the third. So at this point, I'm hoping that these are come pretty natural for you. These are the two shapes that we get with these. Now, when we're looking at a polynomial function, we're going to follow this pattern. We're going to see how many x. We're going to look at the first term. So suppose I had x to the fourth minus 3x to the third plus 5. That's a polynomial function. And I'm going to look at this first term right here, and it's even. Well, any even function is going to follow this pattern that x to the second has. And so it's going to start, it's going to start up here and end up there. It's always going left to right. Now, so I see this one. It is a 4. It is even. So we're going to go from top left to top right, just like x squared. Now, if we have an odd function, this one is going to follow the x to the third pattern, and it is going to start in the bottom left and go to the top right. Okay, now it's possible, however, that they have a negative in front. If I had even and it had a negative in front, we learned already that negatives flip it upside down. So I have an even one that's going to follow this pattern we know, but a negative has turned it upside down. And so I'm going from down here to over here. And then the same with an odd. If it's odd and has a negative in front, that turned this upside down. Well, it normally goes from bottom left to top right. Well, if it's upside down, it's going to start in the top left and end up down here. Now, I'll show you some of these, and hopefully, one of the things, it's interesting, in some of their textbooks, there are tons of examples, but in the college algebra one, there's not a ton. So I hope I'll cover it all. I don't know if I have quite as many as I should have to show you here, but now I don't find this to be all that particularly helpful, but when the graph is moving from left to right, you can know the most possible number of turns that you can have. Take the highest exponent and take away 1, and that's the maximum number of times it can turn. I don't ever ask this question on a test because as you're doing it, it's all just pretty natural how many times it's going to have to turn. But again, it's in there. So the textbooks all ask this. So look at the highest degree. It can have at most one less turning point. So if it was x to the sixth, well, that's a degree of 6. So its maximum number of turns is 5. Now it could be less than that. So that's why it's not even all that helpful. But anyway, it's in there. Okay, now if we were looking at the turning point question, these are out of order. So this is actually the highest degree is 5. So the maximum number of turns there would be 4. Now this has actually been factored. So you'll see this a lot with these kind of problems. In order to solve this, what we would need to do is say there's 2 x's here. And if I had FOILed this out, there'd be 2 more x's here because this x is squared and this is x to the second. So that is 4 x's. So my turns are 3. Now you know what, there's not a lot of these problems. I'm going to use this one right here to show you another example. So let's find our zeros, our intercepts, our x-intercepts. Wouldn't you agree that there's one at 1, has a multiplicity of 2. Now, maybe this isn't going to work because Yeah, this isn't going to work because it's going to have an imaginary solution. So, you know what? Let's fudge it a little bit. How about that? Let's suppose it turned out to be 1/2. Okay, and then it has a multiplicity of 1. I know this is confusing in here, but let's suppose this had just turned out to be 1/2. Actually, I'm going to have to drop this. It's not going to work very nicely. Let's keep rolling here. I'll get you some better ones as we move forward. Let's do one here, okay? This one will work. So if I were to find my zeros, do you see I have -3 and 5? And I like to write my multiplicities behind there, times 1. Okay, now let's start sketching the graph. Now, first of all, we need to know where we start and where we end up. So let's take a look at this. So I have 2x's here. Like, this is not all FOILed out, but you don't actually have to do that to be able to solve this. I've got 2x's here and 1x there. So that's x to the third. Okay, well, we know x to the third follows this pattern, but hold on. It's got a negative out front, so it's been flipped upside down. So this one is actually going to start up there and end down here. So I've got my starting and my ending. I just knew that from the number of x's. The degree that's going to be created is 3. And then I had a negative out front. So I know my start and my end. Now I'm going to mark -3. So there's one of my zeros. I'm also going to mark 5. Now let's add one more piece of information. Let's do the y-intercept. So I'm going to put a 0 in here for x, which is how you find a y-intercept. And so I've got -2 times 3 squared times 5. Okay, so this is 9, this is 10, so I get -90. Now this is way off our scale here, but what it tells me, if I were marking this, I'm getting somewhere way down here. Okay? Now, we have everything we need to graph it. Now, it's not going to be perfect. We're not going to know exactly where all the turns are, how high it is. But for the test, all I'm asking you is to have the basic shape. And so I'm starting here, and I come down to -3. And it's times 2. That tells me that I bounce and start going back up from where I came. Okay. Oh, you know what? Hold on. I wonder what happened here. Okay, this would have been -5. Sorry about that if you caught that. So this would have been -2 and -5, so I should add +90. I wondered why it wasn't going to work. Okay, so I'm way up here somewhere at +90. So again, I knew I was starting here. I came down. I get to -3, and because it's a multiplicity of 2, I bounced. Now I'm going up, and I'd go all the way up there to that y-intercept. And then I know I have to start coming back down because I have another root. And I'm supposed to end down here in this quadrant, so I know I got to keep going. So I come down here, and when I get to it, because it's a multiplicity of 1, that means I just slide right through. Okay, now this is far from perfect, and boy, that looks terrible when I draw it on here, but it gives you the basic shape. Okay, now let's see if we can do another one. Yeah, there's really not enough of these. Yeah, I wish there was some more here, but it's the same logic. Now I'm going to just take you through this one. If you think you already have it, that's fine. I'm going to put my zeros. I've got, if this was solved, I'd get 0, 1, and -3. Now this is times 1. This is times 4. I'm not even exactly sure what that looks like. It's going to bounce, but I don't exactly. It probably bounces in kind of a strange way. I don't know what that is, but we're just going to call it a bounce for here. I would not give you a 4. I would have made it a 2. Okay, so I've got this picture. We need to know where we're starting and where we're ending up. Well, there are 3 x's here, x to the third. There are 4 of them here because there's x and there's a 4th power and there's one more. So we've got 8 of them. We have x to the 8th power. Okay, so, and it's positive. So this is following the pattern of x to the second, the even ones. I'm going to start up here and end over here. Well, I should show it like this because we're going this way. Okay, so I'm going to mark all my zeros. So I've got one right there. I've also got one right at number 1, and then 1, 2, 3. Okay, I want the y-intercept. I actually already know what's going to happen with that. If you put 0 in here for x, you're going to get 1/4 times 0 times 0 minus 1 to the 4th, 0 plus 3 to the 3rd. Well, it doesn't matter because this 0 in the front is going to make everything 0, and it's going to just drop out of there. So, and I actually knew that. When the x-intercept was 0, I knew it was going to be right there. Okay, we have what we need, so let's start building. So we're coming down, and we're heading towards our first one, -3. Now this is a times 3, so it's going to go through because it's odd, and it kind of flattens out, which is really hard to show on here, and then it kind of squiggles through. I'd be real merciful on that on a test too. Just make some attempt to show me that it didn't just pass right through. Okay, so now we've gone through, and I have another intercept right here at 0. And so I got to turn around or I'll never get to it. And it's a 1, so I know that I passed through. Now I've got another intercept here, so we are going to have to approach that guy. And because it's 4, again, I don't know, 4 probably does something really weird looking, but I know that because it's even, it just bounces, and then we end up over there. Okay, now there was only 2 of these, but it's all the same. The logic that I've spelled out here is how you do them all. Nothing changes. So if you need to watch these 2 examples again, go back and try that again. Okay, I think this is it. Last thing here. Let me just say, yeah. All right, this is going to show you how to make the equation from the picture. Okay, and I've already kind of done this in that I have these roots, and I'm going to list their multiplicities. That's got to be 1 because it went straight through. That's a 2 because it bounced, and that's a 1. Now, these are the roots of the solutions. Let's go back the other way. If x equals -3, then x plus 3 equals 0. Do you see? So basically I'm going to just change the signs. So this is x plus 3, and it had a multiplicity of 1, so a 1 up there. This must be x minus 2 with a multiplicity of 2, and this is x minus 5 with an exponent of 1. Okay, now this is a basic version of this function, but there is the possibility of stretches, which means that maybe it wasn't this simple. Maybe there was some kind of vertical stretch placed on the front. So if I were trying to solve and wanted some, I will try to ask the question to make it clear whether I wanted you to have a stretch or not. But if it was a stretch, what you need is to use a point that's on the graph, and then you could solve for a. And so the point that's typically used, you'd use the y-intercept, which is 0, -2. Now, here's what I mean. So I'm going to take this function that I created, and I'm going to say, when x is 0, we get -2 out. So I've got this. Got that. Now, I have everything, I've only got one I don't know. So if I solve this, I can find the value of a. So let's see. I've got a times 3. This would be -2 to the second, would be 4. And this is -5. Okay, so I get 20 here. -20 from these two guys. Get -60. So here's what I've got. Make sure I'm right this time, because last time I messed it up. -20, 60, I believe I'm right. Okay, so now we're solving for a. Send this to the other side. I'm going to jump ahead a little bit. Do you see that a is 1/30? So I now have the complete function. Now again, I might ask the question where I'm not saying that, I might indicate that I'm not worried about a stretch. But if not, you actually have to plug in the y-intercept to find the value of a. Okay, let's do one more of these, and then we'll call it a video, I think. Yeah, we will. Okay, so I'm going to mark my roots. They're -1, 2, and 4. Now let's look what they're doing. At -1, I'm bouncing, so that's a times 2. At 2, I'm going through at a flattened squiggly. Do you see that? So that's a 3. and at 4 I'm going straight through. That's a 1. Okay, so I've got everything I need there. Let's start building the function. Now there's some a in the front. We're going to change the sign. So I'm making it 1, multiplicity of 2. Okay, multiplicity of 1, so it's got an exponent of 1. Okay. All right, so we need to just find a. Well, we have the y-intercept, 0, -4. So let's solve this for a. So I've got -4 equals a times 0 plus 1 squared, 0 minus 2 to the third. That's just going to be 1. -2 to the third is going to be -8. And this is -4. Okay, just tidying this up. So a is going to be -4 over 32, or -1/8. So I've got it now. I've got my final one, and there was a compression actually on the front of it. And there we go. Okay, again, I wish there were more examples of everything here. That's all I've got from the book here. So just if you need to see it, all the concepts stay the same. Just take another look through and go slowly, look at it again. But this really is all that happens. So okay, I hope that helps.